Okay, so just as a reminder, this week, today we're learning something new. Then we're going to start reviewing for a quiz that you guys will have on Thursday, okay, which is the last day you will be here this week. Who can tell me one thing that's going to be on the quiz? Aubrey.
Powers?
What we're learning today. Yes, that will be on there. Dylan?
Adding and subtracting mixed numbers.
Adding and subtracting mixed numbers, and one more thing. Arabella?
Adding and subtracting decimals.
No, that will not be on there. Easton?
Dividing fractions.
Nope, not dividing. We're not there yet. We haven't learned that yet. Emma?
Adding and subtracting fractions.
Nope, just mixed numbers. Rory?
Fractions as division.
Nope, we already took a quiz over that. Kylie?
I don't know what it's called, but like comparing decimals.
Scaling. Okay, the scaling stuff that we did last week where we had to decide are we multiplying by a number bigger than 10 or less, bigger than 1 or less than 1, and then deciding. Yeah, and really that's just developing number sense so that when we actually do multiply by fractions and decimals, we can look at an answer and think, does that answer make sense or does it not make sense? Because there's lots of places to mess up, okay? So we are getting into multiplying and dividing decimals and fractions. So we start with the easy stuff and then work our way up. Today's lesson is kind of comparable to the scaling lesson, where it's more you have to know rules and be able to apply the rules than doing any like real math. You're doing math because you're working with numbers, but it's more you're applying a rule to get an answer, okay? So today we're talking about multiplying and dividing decimals by powers of 10. So first we have to refresh, what is a power of 10? Most people are better at giving me an example rather than putting it into words. Stop. Rory.
A power of 10 is like, it's like a normal power, but you have to multiply it by 10.
Okay. Emma?
It's like something multiplied by 10. And then multiplied by 10.
Dylan?
It's when you have a base and an exponent.
Okay, so that is called a power. It's when we have a power. Okay, more, can you add to that? A power of 10 is a power.
Like, and you multiply the exponent by the base.
We don't multiply the exponent by the base. Brennan?
You multiply the base by the exponent.
Nope, same thing. Madison?
Power with a base of 10.
Yes, it's a power with a base of 10. Okay, and just to correct what you guys were saying, the exponent, we don't multiply the base times the exponent. The exponent tells us how many times to multiply the base times itself. Okay, so it's a power with a base of 10. Okay, so it would look like 10 to the 5th power. Okay, that's a power of 10. Sometimes they could just give us the value of those instead of actually seeing the base of 10 with an exponent. What would all of the values would look like? How would I know value would look like? Any power of 10, that's my alarm going off again. Any power of 10 would look very similar. How can I look at a number and be like, oh, that's a power of 10? What would they all look like? Or Caleb? It will not necessarily have a 10. What numbers are in the number 10? It'll always start with a 1 and have zeros behind it. So it will always look like a 1 with zeros. Okay, and we're just going to write out a couple powers of 10. I know you might be running out of space. That's okay. 10 to the 1st power. What is the value of 110? Dylan? 10. So they could give it to me as 10 to the 1st power, or they could just give it to me as 10. It's still a power of 10. 10 squared, or 10 to the second power? Who knows that value? Kylie? 100, because what is that telling me to do?
Multiply 10 2 times.
10 times 10 is 100, so they could give it to me as 10 squared, or they could give it to me as 100. Okay, what about 10 to the fourth power? Brennan?
10,000.
10,000, because it's a 1 with 4 zeros behind it. Okay, and again, I don't expect you to have these memorized, okay, but I expect that if you see 10 to the fourth power, you know that that is 10 times 10 times 10 times 10. And then we can use our mental math strategies. 1 times 1 times 1 times 1 is 1. And then we add 4 zeros, okay? So today, we're just multiplying and dividing by powers of 10. So all of our problems will either have a 10 with an exponent, or we would be dividing by like 10, 100, 1,000, 10,000, 100,000. Those are all powers of 10, okay? Now, for the rules, you're going to come up with it yourself. I'm just going to give you some examples, okay? And I'm going to see if any of you can come up with what's happening, because it's really just a rule that you will have to follow. You will not have to do much math at all. So I will tell you that 4.6 times 100, which how do we know that 100 is a power of 10? Caleb? It has a 1 with zeros behind it. So this means it has to follow my rule. 4.6 times 100 is 460. Okay, so again, I'm just giving you problems and answers, and you're going to see if you can come up with the rule. So copy these down. Okay. .685, and I'm going to do times 100 on all of them, but again, it could be any power of 10. I'm just trying to get you to see something here. So 9.685 times 100 is 968.5. .043 times 100 is 4.3. I'll do one more. This one's almost, it's common sense, but it still follows our same rule. Now, once you get those 4 examples written down, I want you to kind of look at them and see if you can figure out something that works for every single one of them. Something that's true for every single one of them. Aubrey, what do you think?
That since there's 100, there's a 1 in it, you multiply them both by 1. That's good.
Okay, so what is 4.6 times 1? Don't overthink it.
4.6.
So is that true? So you said we just multiply by 1. I think you mean like the numbers in it stay the same. That's true. So she's saying like the numbers, like if there's a 4 and a 6 here, there's a 4 and a 6 over here. 9685, there's a 9685. 43, there's a 43. So that is true. The numbers stay the same. The non-zero numbers stay the same. Easton T?
The numbers in the places, they move to the left twice. And then
Okay, did they move to the left twice or to the right twice? Easton's on the right track. Something did move twice. Emma?
the digits move 2 times its place to the left.
Madison?
The decimal point moves 2 places to the right.
The decimal point is what's moving. Okay, the decimal point is what's moving, and it is 2 times to the right. So now, if I do this, what do you think of? 10 times to the right. Sorry, your right is that way. I'm facing the wrong direction. So 10 times to the right. If you are multiplying by a power of 10, all you have to do is move the decimal point to the right because it's a times power of 10. How do we know how many times to move the decimal point, do you think? Rory? The value of the power helps us. What do we specifically look at in the value of the power to know how many times to move it to the right? The zeros, okay? The zeros tell us how many times to move it to the right. So now we're going to sum that all up and write some rules at the bottom, and then we're going to do some more examples. The quick rule, just so you can kind of remember it, is times 10 to the right. And again, that doesn't give you everything you need to know, but that kind of gets your brain going. Times 10 to the right. So the quick rule is times 10 to the right. Now, what does it mean? It means you move the decimal point to the right How do we know how many times? Caleb?
10 times?
We don't move it 10 times unless something is 10. Dylan?
Oh, how many zeros there are?
In the power of 10, yes. Okay, so we're going to write that. The number of zeros in the power of 10 tell how many times to move. I'll give you guys a second to write that down, and then we're going to do several more examples. Okay, and there is some work I force you to show, not a ton, but it's really just to slow you down so you don't make goofy mistakes. Waylon, give me a decimal number. 4.5. Our first example, I'm going to write 4. I'm going to start higher. You guys start under examples. I just don't want to have to delete everything. So I'm going to write 4.5 times. Give me a power of 10. A 1 with some zeros behind it. 100? Okay. So that is our work, or that is our problem. To show work, first thing we do is we copy down the decimal number, because those digits, someone noticed they do not change. So I copy it down exactly how I see it. Since this is times a power of 10, Brennan, what do I do?
You add a 0?
No. We will never talk about adding zeros because that only works sometimes. What always works? Emma?
The decimal place as many times as 0.
Yeah. So first, the times a power of 10 tells us we're moving to the right. So draw a right arrow over the top of it. Because what else are we learning today? Divide, which, just guessing, what do you think is going to happen on divide? We're going to move to the left. What do you think a common error is?
Moving to the right.
Moving the wrong direction, okay? So we're going to draw an arrow saying times 10 to the right. And then these 2 zeros, just kind of squiggle under them. Those 2 zeros tell me how many times to move to the right. So then I physically show moving the decimal point. How can I show that I'm moving a decimal point? Arabella? Arrows or loops. So we do it just like this. We start at our decimal point. We have to move it between each number. So that's one spot. See how you can see one loop? Is that where I need to stop? Nope, I have to do one more. So I'm going here. There is my new decimal point. How do you think I write that? Aubrey? What do you think goes in that empty loop?
450.
Yeah. If you have empty loops, they're just zeros. Some people like to actually physically dot them in to show, hey, there should be a zero here. But that is 450. Why do I not need to put my decimal point in my answer? Emalap?
Because the zero kind of replaces it.
It doesn't replace it. Cam?
There's no decimal.
There is, but we don't need it. Why don't we need it is the question. Waylon?
Because the rest of the numbers after are basically all zeros.
Yeah, they're all zeros. It just creates a whole number. Again, we said when you turn on your 11th birthday, you don't say, I'm 11.0 today. You just say, I'm 11. If there's no decimal places behind it, we just kind of leave it off. Okay, let's do another one. Colby, can you give me a decimal number with more than one decimal place? Just rattle off some digits. 658. Okay, and I'm going to write it like this, times 10 squared. If they give us an exponent, that means we just have a little bit more work to do. Milo, what do you think the little bit of extra work is?
You have to do 10 times 10.
Yeah, you have to figure out the value of that exponent. So Milo, what is 10 times 10?
100.
100. So I'm going to go ahead and write that down. That's important to know. Sophia, which way am I moving my decimal point in this one?
Right.
How do you know?
Because it's 100.
And it's times 100. So I'm going to show my arrow over the times sign because that times sign is what tells me I'm moving to the right. Easton, how do I know how many times to move? Who can answer that? Arabella?
How many zeros?
How many zeros there are? There's 2 zeros. So that tells me I'm going to rewrite my decimal. So I have to move it 2 times to the right. So I move it between the 6 and the 5 is one loop. Between the 5 and the 8 is my second loop. So who thinks they know what I'm going to write down for this one? Caleb?
965.8.
Good job. Now, the reason I have you copy down the decimal number is because these are all tight. There's no spaces between the 9.658 times 10 squared. You guys are messy sometimes. Do you agree with that? So if you start moving decimal points up here, depending on how far it is, you go into the rest of the problem and it's just really hard to see your work sometimes. Okay? I'm going to do 2 more on this side and then we're going to go to the back. Oops, didn't mean to do that, but that's okay. Let's do 654.987 times 10 to the 5th power. What do we have to do first, Zach? Drake, did you get this down? Grayson, do you have this one down?
Figure out what 10 to.
Yeah, and if you have to, you can write out 10 times 10 times 10 times 10 times 10. It's not 50. If I'm doing 10 times 10 times 10 times 10 times 10, what mental math am I doing? Brendan?
You could do like 10 times 10 is 100.
You're overthinking it. If I write out 10 times 10, what math problem do I have to do, Colby?
Since you would have 5 zeros.
I would have 5 zeros, and what would my math problem be? 1 times 1 times 1 times 1 times 1 times 1, however many times is always what? No! That's the common wrong answer. Slow down. What's 1 times 1? Times 1. Times 1. Times 1. Times 1. So no matter how many times you multiply 1 by itself, you will always get 1. So Colby is correct. You'd put a 1 with 5 zeros. 1, 2, 3, 4, 5. What other work would I show for this one? Dylan, what other work would I show?
You have to rewrite your whole number.
Okay, I'd write down that ugly long decimal, 654.987.
And then you start at the decimal point and make 5.
So I'm going to show that I'm moving to the right. How do I know how many times?
All your zeros.
All my zeros. So I'm just going to squiggle under those zeros saying, hey, here's where it's telling me I move to the right that many times. Now I show it. 5 loops to the right. 1, 2, 3, 4, 5. There's going to be my new decimal point. This is an amount of money I would like to have in my bank account. My suggestion is copy down the number first and then add in your commas and all that fun stuff. 8, 7. How many zeros do I add to the end, Emma? 2, because we had 2 empty loops. So I'm going to go in and add my commas. Do I need a decimal point in this one? Why not? Yeah, because it would be at the very end. So if it's at the far right side, you don't even need it. If you have it there, it's not wrong. You just won't see it written like that. Questions on that? Okay, flip it to the back. On the back, we're dividing by powers of 10. How are multiplication and division related? Emma was super confident and then lost it. Zach?
Multiplication, you're adding
So multiplication is repeated addition. I do agree with that. Aubrey?
You're still moving, but it's to the left.
But we're not talking about the rules yet. I just said, how are multiplication and division related? It's the same relationship as up and down. Girl and boy. Cat and dog. Dylan?
division increases, division decreases, and multiplication.
You're still right. You're right. Multiplication, when we multiply these numbers, our answer should get larger. Division, it should get smaller. Emma? They are both math problems. Noel? They are in order of operations. How are they related, though, was the question. How are they related? They have a relationship. Rory?
Because they both go 10 times.
Nope. It's not that you're wrong. You're just answering the wrong question. So easy, it's hard. Caleb?
They both have answers.
Kylie?
They use the same numbers.
So I'm going to go back. This is a relationship you learned a long time ago. Up, down, left, right.
They're all directions.
Boy, girl. Multiply, divide. Add, subtract.
Both math problems.
Did you learn that back in preschool? This is a skill you learned in preschool. On, off. Kylie.
You look at the numbers?
Did you learn homophones in preschool?
Yes.
Emma. Tyson. They're opposites. Did you learn about opposites like in preschool? Yes. Yes, you did. So, multiplying and dividing are opposites. Okay, so you do the opposite of, if you know one of the rules and then you're trying to do the other one, it's always the opposite. That's the relationship between them. So I'm going to write down just 3 examples. You probably already know the rule, but I'm going to write down 3 examples and we're going to then figure out the rule. But really, if you can remember it's opposite of multiplying by powers of 10, you can probably remember it. So I'm going to write down 4.8 divided by 100. This one equals 0.048.
You put 6 and then 4.
Oh,
4, 8.
sorry, this is a 6. I said 8 and wrote 6. 74.2 divided by 100 equals 0.742. 0.9 divided by 100 equals 0.009. Callie, what do you think's happening here?
You go 10 times to the left.
Caleb?
You move the decimal how many times to the zeros in the number you divide.
Okay, so Callie was just a little bit wrong. Who knows why Callie was just a little bit wrong? And Caleb just put it in more words. Waylon?
You move the decimal point to the left.
It is, but what do you think the quick rule is? Arabella? Hold on, that's not quick. Noel?
10 times to the left.
1/10 times to the left. Okay? So 1/10 times to the left. And we have to remember that multiplying by 1/10, and in parentheses we're going to write this, times 1/10 is the same as what? Dividing by 10. Multiplying by 1/10 is the same as dividing by 10. So what does it mean? It's the same as the other side, except we are moving to the left. So move decimal point to the left, and that is correct. The number of zeros tells how many times. The number of zeros tells us how many times to move. I'll give everybody a chance to get that down. We'll do a few examples and then I'll go ahead and give you your homework. Anybody still writing? Easton T, you got it? All down? Okay. 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 Waylon, give me a decimal number. 8.9. Okay, 8.9. Audrey, give me a single digit number.
5.
Divided by 10 to the 5th. Again, our work is very similar. First we have, it's divide by a power of 10. So when I see divide by 10, my brain should think which direction? Left. So I'm going to draw a left arrow. We need to know the value of 10 to the 5th power. It's a 1 with how many zeros behind it? 5. So I'm going to show that I know the value of that is this. What other work do we need? Not much more, just a little bit more. Dylan?
You moved the 8.9 down.
Okay, so I just rewrite it exactly how I see it.
And then you move the decimal 5 times to the left.
5 times to the left. 1, 2, 3, 4, 5. There's my new decimal point. Now, when I do this, what I do is I draw my decimal point first. I'm just going to put a decimal point in. I count my empty loops. 1, 2, 3, 4 empty loops. 1, 2, 3, 4 empty loops. And you have to copy down all of the numbers. You can't leave anything off. So 8, 9. Still not the best answer. Emma, what do you think I have to remember on these ones? Yeah, we just need a whole number. But that whole number is nowhere in my work. So I always save it for last. But if there's no whole number, I fill in a 0. That's a number I would not like to have in my bank account because that's it's less than a penny. It's less than a penny. A lot less than a penny. Okay, let's do another one. Let's do 79.8 divided by 10. 79.8 divided by 10. Okay? Same idea. I see a divide by a power of 10. My brain should tell me move to the left. What tells me how many times here, Arabella? Yeah, this one's, there's only 1 0. So 79.8. Move it 1 time to the left. Milo, what's my answer going to be?
7, 9, 8. And then you put
Where's my decimal point?
after the 8.
Look at my work. So it was here. Where did we move it to? We moved it to right there. Our work, wherever our loop stops, that's where our decimal point goes. 7.98. And we can kind of go back to what someone said. When we divide, our answer should get smaller. We went from 79 to 7. Did our answer get smaller? Yes. Does that make sense? You want one more?
Yeah, one more.
Let's do one more. I did 4 for the other class. I'm going to go up. You guys can go down. Let's do 2,348.96 divided by 10 to the third power. Drake, what do I have to do? What's one thing I need to do now?
3 times 10.
Be careful. Not 3 times 10. I have to do 10 times 10 times 10, which is what? Nope. That's why 10 times, let's write it up. 10 times 10 times 10 is what? 1,000. 1 times 1 times 1 is 1. I add my 3 zeros behind it. Okay? What else do I have to think about, Colby?
You have to how many times I'll put the decimal.
Okay, how many times to move the decimal is how many times? 3. How do I know which direction to move it? The divide sign is telling me I need to move to the left, okay? So I'm going to copy down my long, ugly number. When I copy it down, the only thing I put in is the decimal point because that's the most important thing right now. You can put commas in your answer. But right now, this is just my work step. And Colby said we have to move it 3 times to the left. Here's a common error. Don't write this. Just watch. I made 3 loops, but why is that wrong? Mila?
Because if you have, like, in one row, you have 2 numbers.
Yeah, you can only have 1 number in each loop. So people get, I call that going loop crazy. You guys get loop crazy and you start looping all over and you don't loop correctly. So let's start here. We move it once, twice, 3 times. So that's where it's going to go. What will I write down as my answer, Colby?
3, 4, 8.
You have to write down it all. Yep, so 2.34896. Any numbers in the original problem have to be in the answer. The only thing we add or get rid of is zeros. that make sense? Okay, I am going to just set the worksheet on this table up here. You guys can come grab one. There are like 20 problems, but do these take very long? No, and it's 10 of each. Pay attention if you are multiplying or dividing. Okay, guys, I promise there's plenty for everybody. Okay, doesn't matter if you're multiplying or dividing. Does it matter? Yes, that tells you which way you're moving.